So more about today's topic, that is the big data and the non-relational databases. We have split the agenda into 4 primary parts, and we'll take a look at each of them in detail during the course of this entire webinar. The first item on the agenda is taking a look at the big data applications supported within Applications Manager. That would be Apache Hadoop and Apache Spark. And then the NoSQL databases that are crucial to the effective performance of your Hadoop or Spark architecture. So some common NoSQL databases and the metrics collected for them. And then we will take a look at certain issues that can hamper efficient performance of your NoSQL database and thereby hinder efficient performance of your big data applications as well. So what are the key metrics to look out for, how to diagnose these downtimes immediately and rectify them soon, so there's no business discontinuity in terms of service. And then finally, we will see some analytical capability of Applications Manager, wherein we will see how historical data is put into meaningful use, and then based on machine learning algorithms, this data is used to predict the future utilization trends, thereby equipping database administrators to plan ahead about database capacity and the load distribution plans within your big data setup. So item 1 on the agenda was big data applications, Apache Hadoop and Spark. Let's take a quick look at the Hadoop architecture. This is basically a simple representation of what happens in a Hadoop system. So what we'll be focusing on today are the components in blue and red, which is basically the core of any Hadoop monitoring strategy that you are planning to implement. So any data that enters the Hadoop application, the Hadoop system, in fact, is stored in the HDFS layer, which is called the Hadoop Distributed File System. Now, Hadoop has primarily 2 components. One is the data processing layer, the other is the data storage layer. And the benefit or the main point when it comes to employing Hadoop for big data, for handling big data, is its robust processing and simultaneous data storage capability. So the data storage happens in the HDFS. The data processing layer is called MapReduce in Hadoop version 1, and it's called Yarn in Hadoop version 2. But then again, we will see these details extensively in the slides that are up ahead. But when I talk about data storage in Hadoop, one must not confuse Hadoop to be a database of sorts. What Hadoop does essentially is it functions as a data warehouse with rapid movement and rapid processing of data. But the database part, in fact, comes in the form of the NoSQL databases that you can see in red here. So let me just walk you through the core components of Hadoop, beginning with the HDFS, the MapReduce in case of Hadoop version 1, the Yarn in case of Hadoop version 2, and the NoSQL databases, of course, which comprise a part of any big data application. If anybody has any questions during the course of this webinar, our panelists are online. Feel free to ask your queries through the chat panel, and our panelists will respond to you immediately. And of course, we will have a brief Q&A after the end of the session as well. So feel free to ask your questions anytime. So let's dive into the metrics now, the HDFS. Now, when we're talking about HDFS, clearly, as the name suggests, it is a distributed file system, so distributed storage of data. Now, Hadoop follows a master-slave architecture, wherein the name node, as you can see here from the first screenshot, the name node resides in the master node, and what it does is it basically collects data from the data nodes, and then it assembles these different sets of data into meaningful messages before transmitting. And how is data stored in these data nodes? What happens within data nodes is every data node basically runs some aspect of the application simultaneously. And when it is called upon, the name node collects the relevant information from all of the data nodes and then combines it and assembles it into the meaningful message that has to be transmitted. These data nodes, they replicate data across other slave nodes to maintain data consistency. And when we talk about data processing, we are introduced to Hadoop MapReduce. Now, the MapReduce, again, is the data processing layer for Hadoop version 1. And this MapReduce was upgraded to something named Yarn as development moved from Hadoop version 1 to version 2. And the Yarn, in fact, solved certain limitations that existed in MapReduce, which were, for example, the primary limitation was MapReduce had support for only exclusive MapReduce applications, limiting other application support. The Yarn functions as a resource manager, which basically allocates different resources to different sets of applications, Java applications that run across the entire Hadoop cluster. So that is what the Yarn data processing layer hopes to solve, basically, by allocating resources simultaneously for a lot of simultaneous applications and increasing the data consistency factor by a significant margin. So that's about the key components of Hadoop. A quick look at some of the key components of Apache Spark, but first let's take a look at the Spark architecture. Spark also follows a similar architecture like Hadoop, that is a master and slave architecture. And the key components in Spark include drivers and workers. Now, these drivers and workers are just other names for the master node and slave nodes. That is, the master node being the drivers and the slave nodes being workers or executors. The memory and resource utilization metrics, again, very, very crucial component when we're talking about Spark monitoring. Spark core is the backbone of the entire Spark application, in fact, because it is solely responsible for scheduling, dispatching, and even controlling the APIs that define the Spark the resilient distributed data set, which is called the Spark RDDs. So the Spark RDDs, again, important components to monitor. RDD stands for basically resilient distributed data set, which means it is highly resilient, that is, it is highly fault tolerant because of high levels of data consistency. It stores data in a distributed format, hence the word distributed, and of course data set because we're dealing with large volumes of data here. And these RDDs are in fact partitioned across many servers, and what happens is, since they are partitioned across many servers and they run on many different nodes, they can be computed on different nodes of the cluster as well. And of course, finally, the NoSQL database that comprises, that basically complements the big data applications, even for Spark. So some metrics related to Spark, the worker details, you can see in this screenshot, a single worker right here with its web UI address over here, the memory that particular worker is consuming, and the state, whether it's alive or whether it's inactive, and so on. Memory details of Spark. Now remember, every time the executor starts an application, these applications are all individual Java applications that are processed simultaneously across various nodes. So it is important we monitor the heap memory, the non-heap memory of these Java components, the JVM metrics of these Java applications, including other Java metrics such as mark sweep and scavenge metrics. So this basically helps us understand that at each point of time, the status of various applications that are being executed by these executors or workers in Spark. Spark core and Spark applications. Spark applications is nothing but the number of applications that are utilizing the Spark application, how much memory is allocated for each of these applications when it is accessing Spark, how long has this application been running, and the state of these applications, as you can see from this screenshot over here. Some detail about the Spark resilient distributed data set, that is the Spark RDDs. So again, important metric, what we collect here are the compilation details, including the compilation time and compilation count. And right here, you can see the counters, the value for each of the counters. For example, file cache hits and files discovered. So again, some more visibility into the performance of the storage part of Spark. What I'm going to do now is jump to the product and walk you through some of the metrics that we've seen in Hadoop and Spark in the presentation. Click on the Monitors tab, and right here is Hadoop. And this is my Hadoop instance. I'm going to drill down and check out the details that are collected for Hadoop. So the overview is basically nothing but the availability and performance history for the past 6 hours. The duration, again, a quick overview about the status of your overall status of your Hadoop application, the DFS stats, the blocks, how many missing blocks, how many corrupt blocks among the total blocks. So that status can be checked out over here. The files and the load handled by your Hadoop overall, that's present over here. So we're just in the overview tab right here. If I click on the HDFS tab, we will see the details that we were talking about in the presentation. The data node right here, all of the data nodes, how many are live, how many are dead data nodes. So again, this will help us understand the load on each of these individual data nodes and how much application processing is going on in these data nodes, and how well will how will these data nodes perform when it comes for collection and assembling of this data by the parent name node before delivery. So yeah, the different data nodes, the status, the memory, the HDFS memory used, all of those details can be tracked right here. Let me click on Yarn. Now, when I click on Yarn, it must be evident to everybody that we're talking about Hadoop version 2. As we discussed, the processing layer in Hadoop version 2 is Yarn. Well, the Yarn is expanded to a rather humorous expansion, which is yet another resource negotiator. But what it does, in fact, is resource allocation. So it is aptly named, and what it does is allocate the necessary resources to necessary applications across nodes, and then collect these information from these nodes and then process it together. MapReduce used to collect data from all of these nodes and present it in a singular format, but Yarn has the flexibility of processing multiple data and transmitting multiple messages simultaneously. Another limitation that Yarn addresses when it comes to, in comparison to MapReduce. The applications, the overall application summary, that is how many applications have been using your Hadoop application, how many apps were submitted, how many of them were completed, how many are pending or ongoing, failed. So all of these details can be seen here. Let me just take you to this bill here and show you the details in Hadoop version 1. So primarily, the only difference we'll find here is the MapReduce. So you can see here when we're talking about version 1, the MapReduce summary is over here, the tracker summary and the slots summary. So that's perhaps the only difference when we're talking about two versions. And this jobs, again, we had applications in version 2 and we have jobs in version 1. Again, similar to applications, how many jobs submitted, how many running, how many failed, how many preparing, and an overall summary between individual polls also. So when you think about the details we find here in Hadoop, there is barely beyond anything beyond these metrics when we're talking about efficient performance monitoring of Hadoop. And of course, each of these metrics are can individually be associated to thresholds and alarms can be configured. So you have total control when it comes to monitoring your Hadoop systems. Let's take a look at Apache Spark while we're talking about big data technologies. I have a Spark instance right over here. So what I'm doing now is I'm on the inside of the Apache Spark master node, and let's check out a few details in the master node, and then we'll take a look at the worker node as well. The overview tab, there's only one worker, so you can see right here the worker node or the executor is listed here along with its availability and health status. Memory utilization right over here, very, very important metric to monitor, and the overview of your Spark master, or what can also be called a Spark context. So alive workers, the status, the value of the various metrics within your master node. Let me click on the worker node. So we have this one worker as we saw. So how much of the storage is this worker consuming? If you have multiple workers, you'll see more data here about each of those workers and their individual memory consumption and their state as well. Applications, right now we have only one application running, but the more the application, the more the data and the more the resource consumption. So then it behoves us to be proactive when we are talking about launching Spark, because applications consume quite a lot of memory. So it is important that we always stay vigilant about the memory usage of these applications. More details in the memory tab. All of these applications, of course, are Java applications. So heap memory, non-heap memory, and JVM statistics go, without saying, of course, that these are the important components in any Java application for that matter, let alone Java applications running on these executors. So data about that is present here as well. The RDD details we were talking about in the presentation, the compilation details, the counters that are present in your RDD. And the configuration is basically just an overall configuration detail about your Apache Spark system. Let me click on this node here. And what we're seeing right now is basically details about the Spark slave node or the Spark worker or the Spark executor. What we were seeing so far was the Spark master node. So right here is the executor detail, the memory details of the workers. This is not the Spark master node. The RDD details of your Spark worker. So similar details for the master node as well as the Spark slave node or worker node or executor node is present here. So let me just go back to the presentation and continue where we left off, which would be the second item on today's agenda, the NoSQL databases and big data setup. So as you can see from this screen, all of the popular NoSQL databases are supported within Applications Manager. However, what I'm going to do is take a few databases as example today, MongoDB, Cassandra, and perhaps the Redis database, and that should be enough to demonstrate the abilities of Applications Manager when it goes when you're talking about NoSQL database monitoring. Let's take MongoDB as our first example. Some primary components that are monitored include the connection statistics and the network statistics. Of course, the network statistic is important because this can help unnecessary hassle in detecting network issues that might be hampering your database performance. Instead of pointing fingers to the network team or the database team or the application team, the Applications Manager console kind of bridges that gap and eases that diagnosing efforts. connections help us understand how many more connections can the MongoDB instance allow and how many are being used currently. Lock and assertion errors in MongoDB, other important metrics. MongoDB uses a locking mechanism, which basically allows multiple users to read or basically perform read or write operations on the same set of data while maintaining data consistency across nodes. So that is the kind of locking mechanism that is employed in MongoDB, and that detail is captured right here in the product UI. Assertion errors are common types of errors noticed particularly in MongoDB. These can be message assertions or user assertions based upon internal server exceptions or based upon any process or any operation triggered by the user. So the type of asserts or assertion errors are captured here in this screenshot. The Cassandra CPU usage is again another important metric, but when we're talking about any database, for example, the CPU usage is one metric that goes without saying is a very important metric, because if your database is consuming a lot of CPU, it basically means that your database is running out of processing power, or it is running out of memory, which is why it is posing a huge load on your CPU, and it definitely is cause for concern. The Cassandra key space latency, again, important metrics. Read latency and write latency is nothing but the time taken to complete a read request or a write request, but then monitoring this gives us the understanding about the delay in request processing that might be happening within your Cassandra, and just where exactly the problem could be. For example, here you can see the various requests and the latency for all of those requests. So you see an unusual spike here, you immediately get notified, provided you have configured thresholds for the same. Redis details is again details about the number of keys that are present in Redis, the number of expired keys in Redis, and so on and so forth. Basically, again, visibility into the performance of your Redis database. When you look into the product, we will see more data about that are collected for each of these databases. Redis clients, the number of clients connected. This is similar to connections in MongoDB, except here we call them clients. That is how many users or clients are accessing your Redis database currently, how many of them have been blocked, and similar stats. So what I'm going to do now is walk into the third part of the agenda. And after we have taken a look at this, we'll go back to the product and then see various metrics and certain key metrics that we have to concentrate on in order to diagnose these issues in the NoSQL database. So the most important metric that goes that has to be monitored, and this one of the primary metrics to monitor when we're talking about any database, let alone NoSQL databases, is the memory utilization. Again, if the memory utilization exceeds a certain established threshold, it is a huge cause for concern, as this can possibly cause catastrophic losses to business service delivery. It means your server has to be upgraded. It means that your database is, your server is running out of memory because of excessive consumption by your database. Replication is another metric that is very important when we're talking about diagnosing issues. So all databases, the NoSQL database, including MongoDB, use replication, wherein data is replicated across various nodes. This is done for maintaining consistency and faster accessibility of data. So to monitor this replication stats, that is how many of these operations have been replicated, that is, let us take for example replicated inserts here. So how many queries per second have been processed, and if you see an unusual spike in any of these metrics, you know you will have to get your hands on deck and start troubleshooting them for performance problems. Cassandra memory utilization, the free memory and the use memory, again, important metrics even for Cassandra, similar to MongoDB. Cassandra cluster is something that has to be at the top of our minds, particularly in Cassandra. Cassandra is a resource-intensive database which has a lot of monitorable components, as we'll see in the product UI. But then the cluster and the node details help us understand the load that each of these nodes are handling. As you can see from the bottom part of this screenshot, each of the nodes are listed on the left and the load handled by each of these. So basically all of these in the end relate to the memory statistic. That is, if you see the load handled by a particular node is excessively high, you have to be proactive in deducing that this will pose a memory consumption challenge going forward. As we discussed in the agenda in the starting, the forecast reports can help you mitigate these or prepare for such challenges proactively. The memory utilization of the Redis database, again, similar to MongoDB and Cassandra databases, how much memory is used and what is the highest memory used at any given point of time, which is a peak used memory, and the replication stats of a Redis database as well. So these are some of the details that we should always keep at the top of our list when we are trying to diagnose problems in NoSQL databases, but more about the details in the product UI. So I believe all of you can see my screen, the product UI. I'm in the monitors tab of Applications Manager, hundreds of technologies supported within the product, but of course our focus today is limited to the NoSQL databases and the big data technologies. I'll show you some details captured within the Cassandra database. Let's begin with Cassandra. So I have many instances. I'm just going to take this one instance for demonstration. So this instance of Cassandra, when we're looking at the performance tab, the very first metric that we find is, of course, the CPU usage and memory utilization given their importance. And then we see the exceptions, storage, the operational latency, and scrolling down further will show us more granular details about the connected clients, how many of these clients are native clients and how many are thread clients, the mem table stats and Bloom filter stats for Cassandra DB also are collected and presented in this tab. Let us take a look at some key metrics. We spoke about cluster stats. You can see, as we saw in the presentation, a single screenshot. So how many nodes are live? All of those nodes are listed here, and then the corresponding load handled by each of those nodes is also present here. So this kind of visibility can fasten the process of detecting issues. Messages, the various types of messages, how many messages of this type have been dropped, how many in the recent past, that data can be found in the message tab. The request details is a very important tab which has a lot of data to the granular level. Right here we see for a particular request the amount of stages it has to cross within the Cassandra database for it to get processed. So the number of requests in the counter mutation stage, as well as the count of requests that are active, the count of requests that are pending or blocked. So all of those across various stages, the read repair, the read state, the read request response stage, as you can see here. So this kind of deep visibility again gives us, or gives database administrators the flexibility to quickly pinpoint issues. For example, let us say a particular blocked task here is hampering the smooth processing of requests within my Cassandra database. I can associate a threshold to this metric right over here to get notified about any potential performance issues that might be hindering efficient performance. So attribute level alerting configurations can be made to give more control to database administrators. Finally, the key space details will show you the latency. We were discussing about the total number of processes, and the latency for each of those processes can be found here. So this is about Cassandra. Let me go back and maybe show you MongoDB. So right here, I'm going to take this instance of MongoDB, show you a few statistics. Now this has fewer metrics because Cassandra is quite obviously a very complex database, so the number of attributes that we need to monitor also increases likewise. But when we're talking about MongoDB, beginning with the memory utilization, response time, the network and connection statistics, as well as the database operation counters and the assertion errors details can be found here. Log details we had discussed already in the presentation, which basically the locking mechanism allows data concurrency and allows multiple users to perform a simultaneous read or write requests in the same amount of data without breaking the consistency in that data across various nodes. And the page faults are also graphically captured over here. Let me scroll up, go to the replication tab, show you some details about the replication. We saw similar stats in the presentation as well. The number of queries replicated or executed per second can be found over here. We scroll down further, we see some data about the shard as well. It's not just the replica count, but also the MongoDB shard count is present here. So that was about the key metrics that we capture in NoSQL databases and the kind of flexibility it offers when it comes to configuring thresholds, configuring alarms, and getting notified in due time about performance issues so we can troubleshoot them immediately and maintain that seamless business service delivery at all times. Now, when we're talking about NoSQL databases, or when we're talking about big data monitoring, in fact, any big data monitoring strategy would be largely incomplete without a NoSQL database monitoring strategy employed alongside, because clearly the reason big data technologies depend or use a NoSQL database is because of their improved performance as compared to the traditional relational databases. And NoSQL databases clearly excel at storing unstructured data at huge volumes. And given businesses where your website or your web application processes huge amount of data or experiences huge amount of traffic, it is only fitting that you combine your big data technology with a NoSQL database, which is basically an excellent database at storing unstructured data at huge volumes. So NoSQL monitoring and big data technology monitoring together comprise the right big data monitoring strategy. So going back to the presentation and diving into the fourth and final part of today's agenda, which would be how to use applications manager to forecast utilization trends of your database, of your servers, and then subsequently using this insight to plan capacity for the future. So a quick look at certain slides before we dive back into the product one last time and see these details captured in the UI. So the trend analysis report is nothing but a quick glance of various attributes and their performance over a course of a day, a week, a month, or any custom time period. This basically allows us to compare the performance of similar applications. Assume we have two instances of MongoDB, both of which function on similar business services. So comparing these two instances of MongoDB can help us understand which MongoDB is more effective for a given business service, And if the nature of business services are same, why is there a deviation or variation in the performance statistics of the MongoDB instance? So that kind of comparative analysis and correlation can be derived with the help of a trend analysis report. And of course, this does not just end with historical hour of the day or day of the week reports. It also combines some statistical charts and heat charts to showcase some more deeper insights. Here is the comparison chart, as I was telling you just moments ago, about different databases or any different applications, similar applications, and their performance comparison across or over a course of a certain time period. The forecast report basically helps you balance hardware costs with computing needs. What it means is it allows you to make use of historical performance data, real-time historical performance data about your databases, couple that with some machine learning algorithms, and then almost accurately predict what the future growth and utilization trends would be. So this gives you a fair idea about how the performance stats or how the database numbers are going to look like in the future, and get a reality check as to whether your organization or your team is prepared or under-prepared for these ensuing challenges. So these can again help you make informed decisions about resource redistribution or capacity upgradation for the future. Going back to the product one last time, and we'll just analyze a few analytical capabilities right here. If you can follow my cursor, I just clicked on the reports tab, and right here on my left I can see a list of various types of reports. These reports can be accessed for individual attributes across different modules, that is servers, application servers, databases, so on and so forth. Let me just begin with the trend analysis report. I've taken the trend analysis report, and what I'm going to do is maybe take the Cassandra database. So the at a glance report will give us a quick look at the various attributes and their daily performance, or weekly performance, and basically any time period that you would want to see it for. Downtime history will give us the summary of the downtimes that this particular instance of Cassandra has had. This is for today, but of course you can expand this to suit the time frame that you would want. And if you scroll down, you will find detailed information about the uptime across this course of time, and how long did it take for the particular instance to get back to its working state, that is the mean time to repair, as well as the mean time between failures, that is 2 consecutive failures, is captured here. And right here is the attribute-wise trend analysis that we were talking about. Let me just try and get data for Cassandra. Gives us information about the history report. Let me just maximize this for better visibility. The hour of the day report of this particular Cassandra database. Now, when you pull this data out for many instances of your databases, then it starts to make real sense, because then you kind of can correlate and understand that at which particular hour of the day was the consumption value maximum, and correlate that to the peak business service performance, and understand that, okay, so at this time of the day, the database is expected to be overworked and prepared adequately. So that is the kind of insight these trend analysis reports are designed to provide. Day of the week, the statistical report, and finally the heat chart can be seen here. So that is the trend analysis report. Let me just quickly click on the database report. So you see all of the databases listed here. I'll just click on Cassandra, and here you can find the attributes that you want to collect for, or the attributes that you would want to see metrics for. Let me just click on health of databases. Right here, you can see the various instances of Cassandra and the health statistics. So yeah, in the database server tab, you can get the data for all of the databases that are added within your applications manager instance. Finally, let's just take a look at the forecast reports within applications manager. I'm going to select database servers, Cassandra, taking some metric from the Cassandra instance that I have running on my setup. I will just visualize how the forecast reports look like for this particular instance of my Cassandra monitor. Let me just take, yeah. So right here, you can see for the disk utilization, this is the growth trend, this is the forecast by utilization trend, and this is where it is kind of important for database administrators to focus. So these are the problematic zones which tell you that, all right, the utilization forecast for 1 month is already exceeding the optimal capacity. So this is the kind of insight that it is designed to serve. A 4-month prediction is again giving us an idea about the load these instances will handle. So right here is the disk utilization, the average, and the time period across that we have used to predict this forecast. Let me just close this and take some metric within Cassandra and see if the graph gets populated for any particular metric. These forecast reports are not just limited to one metric. There are certain metrics for which you can see the forecast trends, the critical metrics, in fact. So, for example, right now we saw disk utilization. This could be reads per second or writes per second or any granular metric like that. Just bear with me for a few seconds until this report loads, and we'll go back to the presentation and approach the end with a quick recap of what we have seen so far. So there it is. So last 15 days, there hasn't been much activity on this particular instance of Cassandra. So you see that the data is very minimal. However, if you scroll down below, you will see the breakdown where you can see that the values are very minimal, negligible enough to be plotted on the graph. But however, I'm sure all of you understand how the forecast report works and just what the purpose of these forecasting reports are. Going back to the presentation, and let me just quickly walk you through the things we have seen so far. I've noticed a lot of you guys have had a lot of questions that you've been asking through the chat panel. Just a quick recap, and then we'll be open for Q&A for 10 more minutes where we can discuss further about the questions discussed and more. So we began with the big data applications, that is Apache Hadoop and Apache Spark, the metrics to monitor, the NoSQL databases that are the most important components in any big data framework. Obviously, given their importance in big data frameworks, it is equally important to monitor for issues in these NoSQL databases to maintain the overall business service efficiency across NoSQL databases and your big data applications, and then how to be prepared for the future and how to best utilize your databases capacity with the help of machine learning powered analytical feature within applications manager. So that brings us to the end of today's webinar session. I hope and I believe that there has been certain learning experiences through the course of this webinar.